Alright guys, this is the last new thing from chapter 2, and then we'll start reviewing. We'll probably do quite a bit of review. The test will be Tuesday, I think, but this is the last new thing. So basically we've been told so far that everything is normal, right? So it has to say it's approximately normal, or you have to be able to determine if it's normal, and then you can actually use all the stuff we've been using. So we've got this data for unemployment in the United States, and we've got 50 states and everybody's unemployment rate. So the first thing you want to do is plot the data in some sort of histogram and make sure that it actually appears to be approximately normal. Okay? So plot it in a graph, check and see if it's approximately normal. The next thing we can do is use the 68, 95, 99.7 rule, which means we're going to have to count up some values, and we're going to have to find the mean and the standard deviation. Alright, you guys all know how to plug them into your calculator and actually do one variable statistics, right? So you don't have to calculate the mean and standard deviation. Everybody good with that? So we would do that, and we would get a mean of 8.64% for unemployment and a standard deviation of 2.23%. Okay. So how do we find the percent of data? What numbers actually go between to get that 68%? Anybody remember? Yes. One above and one below the mean, right? So I'm going to take 8.64, and I'm going to add 2.23, and I'm going to take 8.64, and I'm going to subtract 2.23. Everything in between those two numbers, that's 68% of the data. If it's normal, then approximately 68% of the data is between one standard deviation above and one standard deviation below. So if we subtract, we get 6.41 and 10.87. Alright, so in between this percent and this percent should be 68% of the data. What we would have to do is go back, and I would count up how many numbers do I have between 6.41 and 10.87. So 6.41, so that would have to be this guy, this guy, this guy, this guy, this guy, this guy. Right, count them all up. All right, and you should get 35 of them out of, how many states do we have? 50. Okay, so what percent of the data is in between one standard deviation? Yeah, 70%. So that's pretty close to 68. Okay, then we would do another standard deviation. So that would be 8.64, and we would subtract 2.23 and another 2.23. That'd be two standard deviations below, which is 4.18. And we would do 8.64 plus one standard deviation plus two standard deviations, right? And we would go from there to 13.1. Now we count up the 35 scores we already counted, plus anything else that I didn't already cross off that's between 4.18 and 13.1. So I would add this one and 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 this one, right? All the way, and all the high ones all the way up to whatever I got. And just so you guys know, once you count those up, you get 48 states out of 50 that fall within two standard deviations of the mean. What percent is that? Okay, so 96%. That's pretty close to 95. And our final one, we would subtract another 2.23, right? We'd go 3 standard deviations below, and we'd get 1.95. And we'd add another 2.23 over here, and we'd get 15.33. And let's see, all of our data falls in between 3 standard deviations. That's 50 out of 50 states, so 100%. So this is one way to assess normality, is to see if it matches pretty close with the 68, 95, 99.7 rule. Okay? The other way is to make what's called a normal probability plot on your calculator. Okay. So we're going to go to our calculators. And you guys know how to go to add lists, right? Everybody go there. We're going to enter all the unemployment rate in. And I want you guys to go ahead and do this with me. Okay? I already entered mine in, so I'll read it for you guys. So let me pause my... Oops, I need to get off of Sparking. All right, ready? Just deal with whatever you have, okay? Here we go. So, you guys are going to go, if you have the Inspire, Control Doc is plus a page. Control Doc adds a page, okay? And we want to add data and statistics. Is everybody doing this with me? Just do it on whatever you have. Do you have any data in? Yeah, just do what you have. Oh, because you have that one. I'll help you in a minute. Yeah, stat plot. The last one on the very bottom right. Okay, go to add a variable and add unemployment. Oh, did you guys label that? I forgot to tell you. Sorry, hopefully you did. If not, go back and label it unemployment. So this gives us the dot plot, right? Oops, sorry. Now what you want to do is go to menu, plot type, and it has this lovely thing called a normal probability plot. Should turn in to this lovely graph. So what I have down at the bottom are our data points for unemployment, and over here on the y-axis is our expected z-score. Okay, so it's plotting it against their z-score. If it's linear, then it's normal. Okay, linear means normal. So because we have about a line, and it doesn't have to be perfect. This one's pretty perfect. If it's pretty close, all right, if it's linear, that means you have a normal distribution. Again, just so you know, on the Inspires, and hopefully you guys did it this way on the other ones, I'll show you guys in a minute. Down here, you always have your X values or whatever your observations are. And over here is our expected z-score. So let's see what it looks like if it's not normal. So let's read this real quick. If the points on a normal probability plot lie close to a straight line, the data are approximately normally distributed. Systematic deviations from a straight line indicate a non-normal distribution. Outliers appear as points that are far away from the overall pattern. So here's one that's not going to turn out normal. So we've got survival times in days of 72 guinea pigs after they were injected with an infectious bacteria. Nice. Isn't that sweet? Someone's got to be against that. All right. Determine whether these data are approximately normal. So if you look at the histogram, you can also tell it doesn't really look normal, right? It looks a little skewed. Over here, we did the normal probability plot. Okay, so we plugged it into the calculator and did the normal probability plot. So if you look right here, it looks linear for about here. What happens to the data? It starts to fall off to the right. That means it is skewed right. And you guys might want to just kind of sketch a graph of that and what it looks like so you know. If it starts to kind of curve off to the right, away from where the line is, that means you have a skewed right or skewed right data. Similarly, if you have a line and all the points are sort of matching up, but they start to fall off this way, that would be a skewed